computer select to be as something gives flexibility on asynchronous attendance is the synchronous session. So if you have any questions, I would have to go through. We really have to invent the wheel when we talk about spatial decision making. I mean, we're going to see a lot of theoretical background and calculations of decision rules and etc. So are they only custom made and tailored to spatial decision making? How is it different than the other decision making in other sciences? Well, obviously we don't have to because there's a huge history and body of knowledge on the decision theory, not just the special science, and identifying the optimum decision, not the single solution, obviously, has been a concern. A lot of scientists, included but not limited to economists, mathematicians, data scientists, psychologists, biologists, philosophers, and social scientists. So you might think, what is the optimal then? Do we really have to or have the ability to find the ultimate answer to life, the universe, and everything? As I said, no. I mean, I wish we could. Well, optimality is often determined by considering an ideal decision maker who is able to calculate with the perfect accuracy and is, in some sense, we expect also full rational decision. And we're going to see through the semester that we don't have an exact solution to most of our problems, but however, we will see various ways to compare several options by using analytical models. So how we are going to move from the theory to the practice, and this is how the course also designed. So we're going to see the theory first, and then we're going to do a lot of applications. The practical application of this perspective, prescriptive approach, the decision maker, is called the decision analysis, and it's aimed at finding tools, methodologies, the software, which is called decision support systems, to help people to make better decisions. And trust me, although we'll be dealing with maths, like the numbers, and some needs to be some calculations and whatnot, we are unconsciously doing in everyday life. We're doing decisions, we're making decisions. But like computers, we are really good at hiding all the process behind. Like computers are based on zeros and ones, the binaries, but we're not seeing a binary or zeros or ones when we look at a screen, right? We're seeing colors, we're seeing lines, points, or whatever staring in front of our computers. And as humans, we do the decisions a lot, and while we're making that decision, like figuring out the objectives and compare the different alternatives and evaluate various criteria by thinking which one will be the better option, which is the most desirable before we come to a conclusion. So what is this special thinking then? Well, as I said, there are so many professionals, scientific areas that do decision analysis, but geographers are concerned with space. And we study the location of things, the conditions at different places, and the connections between places too. And we mostly think about the world in spatial terms, and which also allows us to describe and analyze the spatial patterns and organizations of people, places, and environments on Earth. And any event can be viewed spatially, such as the spread of a disease or earthquake activities, sustainability or immigration, you name it. And a geographer visualizes and analyzes the spatial relationships between the objects. And we use the concepts such as location, distance, direction, shape, and pattern a lot. And it's more than location knowledge and the map skills that you have already experienced within the other JS classes that you've taken, but it's all about seeing the maps as a representation and develop like spatial awareness, which put by David Lambert, defined as the ability to recognize, interpret, and understand the spatial patterns, distributions, and relationships. So that's what we see as a spatial thinking. And the power of spatial thinking resides in its capacity to provide an understanding of structure and of function. And so let's zoom into the sentence and understand what we mean by the understanding of structure and function. So by an understanding of a structure, it's meant as a description of how something is organized. So what parts is where in relation to other parts. And we are not only looking at the spreadsheet anymore, we can capture the arrangements of objects in space and speak about the order or the relation or the pattern is my favorite, how a pattern is changing spatially. And by function, we're trying to say that the understanding of how and why something works, like how something changes with time is a function, right? Or we would like to explain the reasons for changing arrangements of time, writing special patterns like the dynamics. Therefore, spatial thinking is not static, so we can also consider the dynamic processes that allows us to describe, explain, and predict the structure and the function of objects and their relationships in the real or imagined spatial worlds. And it allows us to generate hypotheses, to make predictions, and to test their consequences, obviously. So why do we need to support decision makers spatially? Obviously, spatial thinking is important, but how it's important in the spatial decision making. So we have objects in the space and we describe it in order to capture or preserve or convey the appearance of and the relations among them. And then we can understand the structure of objects by an analytical function. And finally, we can generate answers to the questions about the evolution and function of objects. So we describe it first, convert into a form that we can understand better, and finally solve it. And the typical case of a spatial representation is cartography. And we can see three functions of spatial thinking at work in a map reading and interpretation in its simplest form. And the most common available map form, like a road map, as you can see, provides a two-dimensional picture of the part of the world and depicting places and the roads that connect them. And the spatial thinking is the analytical and inferential process that allows us to select a route, for example, connecting two places and subject to the criteria and such that the road is easy to follow. For example, it contains a minimum number of decision points, like intersections, turns, and etc., and that and whatnot. So let's look at what are the special decision problems looks like. We're going to see a lot of them, and in your final project, you're going to select a couple of them of your preference too. And it's not hard to find them, I would say. Anything with a special attribute goes into the pot. But what can they be? Sometimes they're so obvious because the final output is specially represented, but sometimes the intermediate steps make it special. It's a special decision itself. So sometimes the end result doesn't have to be a map, but the intermediate processes, you produce special outputs in order to get that final output. And what are the characteristics of the special decision-making problem? What makes them unique? Because they have special characteristics to start with. There's a large number of decision alternatives, so we're selecting among them. And how those alternatives are evaluated on the basis of multiple criteria. And some of the criteria may be qualitative, while others might be quantitative. And decision makers have different preferences. And they might be singular or plural. So there might be a single decision maker or a couple of decision makers. And they're typically surrounded by uncertainty. And usually this uncertainty linked with the preferences, because everybody wants their favor. So that also brings a subjectivity in decision making. And let's see the recipe. I also read that some of you love cooking, and I love giving analogies on cooking to baking, particularly, not just generally cooking, but I love baking. One recipe to bake them all. We have to identify the problem first. What is the problem? What we're going to look at? What are the real situation ongoing? And then we have to gather more information about the problem. And how can we solve that problem? We need to develop some alternative solutions and then evaluate those solutions in order to see which one is the best one. And when we talk about the optimization and comparing the solution, salesman problem is the most common one. And I think I have the slides on the Tuesday's classes, but I forgot to include here. But that's a little bit complex problem, but a very typical one for this case to compare the alternatives and decide which solution best solves the problem, and finally implement that solution and determine its effectiveness. So there are a lot of elements attached to multi-criteria decision analysis, and this is a term that you'll be hearing a lot in the couple of weeks. It is how we try to get a final optimum solution by comparing some different criterion and their preferences. And on the top of the hierarchy, we have the goal, the ultimate goal, or set of goals that the decision maker attempts to achieve. And the decision maker or group of decision makers involved in the decision making process. And along with the preferences with respect to the evaluation criteria, right? So maybe they would like to have one objective more than the other one, or they would like to evaluate all of them equally. And a set of evaluation criteria makes the evaluation alternative course of action. So the decision alternatives are the action variables, and the set of uncontrollable variables or state of nature, like the decision environment. And finally, the outcomes or the consequences associated with the alternative attribute pair. For example, in land use planning, the goal maybe to improve the quality of life in a particular region. Complex decision problems typically involve a number of decision makers, as I said, and a decision maker may consist of a single person or a group of people, such as a governmental or corporate organization, and they may or may not have the same objectives, such as, let's say, decision maker one has same objective two, but decision maker two. Let me just take my highlighter and laser pointer and show you. So here we have decision maker one sharing the same objective with two. And this decision require analysis of these values of the decision makers. And they are often characterized by unique preferences. And we sometimes call them as weights. So how we are weighting these objectives, which one is more important than the other. That's the relative importance of these criteria. So alternative excuse me, decisions are evaluated based on these preferences. And a criterion, the singular version, is a standard of judgment or a rule to test the desirability of alternative decisions. And it's a generic term that includes both the objectives and attributes. Any multiple criteria decision problem involves a set of objectives, a set of attributes, or both. And when we say the objective, it is a statement about the desired state of the spatial system, like the desired pattern of land use. And sometimes an objective can have several attributes attached to its. In the case of objective one here, we have attribute one, attribute two, and attribute three. And all the decisions are made in some kind of environment and therefore involve many factors beyond the control of the decision maker. And these uncontrollable factors are referred as the state of nature or the states of environment. And the term nature used here, like general unpredictable decision-making environment, like the economy, like recession, inflation, and a weather condition, for example, rain, drought, frost, that's unseeable, unforecastable. And an action or a competitor or other situations over the decision maker has little or no control also, and therefore they must be also included. The unpredictability of the nature of decision making, and each state is assumed to be independent of the other state, and it's also assumed that a finite number of possible states of nature can occur. For example, the degree of uncertainty about the decision outcome consequences, and there's a possible outcome as shown, and which outcome will actually follow a decision depends on the state of nature. And I know all these terms are abstract on you, so now we're going to see a real case example to make them more concrete. Some more common examples of spatial decision-making problems are land use suitability, site selection, and plan evaluation. So in a land use suitability example, the goal may be to identify the best spatial pattern, as I said, like urban area, agriculture, forest. And in a site selection case, which is another common spatial decision-making problem, a facility might be looking to find the best location for the next site to investigate. And we can also evaluate the plans, comparing pros and cons to get the best out of the proposed one. And of course, I will show an example on the land use suitability because I spend a lot of time in this conservation reserve program with 2 different lands suitable to models in the past. And this is example one of them. Maybe some of you are already familiar with the subject, but in the United States, there's an ongoing practice called conservation reserve program, which executes the land use evaluation and improve the conservation by renting highly erodible cropland and environmental sensitive acreage from farmers. And they also ensure plantation of species that will improve the environmental quality. It is an ongoing practice in Michigan, where my case study was. And it is achieved by a score-based system called Environmental Benefit Index. It depends, this index is calculated based on 5 environmental factors, which are wildlife, water quality, erosion, enduring benefits, and air quality. So these are the different criterion that goes into the decision making. And every factor has a different preference, right? So they might be all equal. So if let's say you would like to give some weights to this different criteria, you might select all of them to be equal, but maybe you would like to have a wildlife objective, so that you would like to increase the importance of the wildlife in your decision making. So you're going to give a higher weight or relative importance in the wildlife factor, and trying to lessen the rest of the factors before coming to the final decision making. And decision makers come up with different preferences for each criteria, and they're also combined into a single score. And finally, when the overall score is, has a higher rank for the predetermined threshold value, then for this particular case, that land unit is left uncultivated for that term. And this is a typical example of multi-criteria decision, because we have various criteria, and then we are evaluating them all together in order to get a final decision. And as I said, we're going to return to this problem throughout the semester. And let's look at the second one to dig more. This is another site selection problem, and I want you to let's read it together in order to, especially by paying attention to bold keywords. So here we have a site selection problem at hand, and we need to find a place where people might live in the future. And we want it to be the best possible economical option, obviously. However, we also don't want to harm the environment, specifically wetlands and mangrove forests. So the case study is as follows. The Villa Union region is located in the Sinaloa province on the Pacific coast of Mexico. And Villa Union, the main city of the study area, has a population of 60,000, and study areas covers 500 kilometers square, and regional has experienced a significant population growth in the last 10 years or so. So this is the background of the region, but let's see what is the problem. Substantial industrial and mostly light industry associated with the processing of fishery and agriculture products has developed and continues to support further expansion. And the region is also characterized by a system of coastal wetlands and mangrove forest. This requires considerable effort to protect the environment. And the challenge facing planners and decision makers in the area is to effectively balance the development of economic growth with environmentally sound practices, so as to guard against the environmental degradation. So yes, the decision problem is a site selection. And the goal becomes to identify the land zones for future housing development. And this goal should be achieved by resolving conflict between economic and environmental objectives coming from two different decision makers. And economic objectives are cost of land, environmental objectives are wetland protection. And given the concerns expressed by the local planners, decision makers, and the data availability, these two main objectives can be described in terms of several sub-objectives. Economic objective may include the cost of land acquisition, access to infrastructures like the roads, city, and airports, and access to water sources like the walls, rivers. And there's also some concerns about the potential flooding along the main rivers. And these objectives can be also considered both economic and environmental. And in addition, the protection of wetlands is taken into consideration too. So you heard the story, and now you're going to try to frame how we can draw the goals and define the decision makers, objectives, and alternatives, depending on this story. And I want you to work on this in groups and then finally submit it into the link. So I was just planning to show you some of the previous year's examples where they're around the same thing. They're very similar to each other. Some of them, they show that and then you might think why I'm looking down. I have to just make sure that this is here so that I will use my laser pointer. Okay. So sometimes two decision makers can share the same objective or can look at the same data, or flood potential, for example, could go into the economic objective or environmental objective too. And here, when we talk about the different attributes, there are definitely the JS layers that we will be looking at. I was planning to give a short, very, very short Python break because I read like a lot of people feeling really not ready about maybe Python. I don't know, but I just want to do a quick demonstration to show you or just get used to some basics before we delve into the upcoming weeks. Let me ask first, does everybody have ArcGIS Pro installed on their laptops now? Okay. I will show you again. So this is the ArcGIS, okay, Pro. And I went to the insert ribbon on ArcGIS and I clicked a new notebook. Probably you're going to, if you're in the map, you're not seeing this, but if you go to the insert, you are going to collect a new notebook and it will create you one. And I also showed where's that? This is the link that I put on the chat. If you don't have the ArcGIS Pro, you will be able to, what happens if I close? Yes, you are going to see this screen once the binder does its magic. And once you click this, you will have a similar screen without installing ArcGIS. Okay. So on my notebook, the first cell automatically created becomes a code cell, and I can write a Python script here. And in my first script, I'm just going to print something on the screen. And maybe we can just type hello, but Notice that I have the parentheses and I have quotation marks. And this makes magic. This makes Python to understand what I'm saying. And you can click on this small icon here or just press the run and it will type hello. Okay. Is this scary? Less scary? I don't know. Did everybody try this? First of all. Okay. Did it work? Can we do some math? Like 2 plus 2? Can Python handle this? Let's see. Oh, no, I won't do 2 plus 2. I will do 6 times 7. What is the ultimate answer? Let's see. 42. And we can try this on the link. Where is that? Here as well. It should work in a different way. And here again, I can run it and I can see the 42. So whenever, if you need a Python shell, if you'd like to run something, you can use my GitHub links to reach out these notebooks. You don't have to have ArcGIS, QGIS, anything installed in your system. This is what Binder does. But usually I don't go too much in detail on this because that makes things complicated. But in ArcGIS, the things that you're using every day, you have the notebooks, you have the power, you can do lots of Python-based computation. You don't have to install anything else. And this is possible through the notebooks. Like it or not? No feelings. Okay. Maybe you can try printing out something different later on. This is the simplest function that you're going to use. All right, what time is it? We have just 2 minutes. I don't think we're going to complete this. Do you have any questions?